Good day, grade 11s. I believe you guys are doing pretty fine. I want us to look at some question, but before I do that, I just want to do a very quick revision on these vectors. As you can see, the caption today is vectors into dimensions, and by now we understand that when we talk about a vector, we talk about a physical quantity that has a magnitude, and direction. So about the pattern writing, magnitude means a size, and the direction. For an example, we can have a vector going in this direction. We can have a vector going in that direction with a size of 400 Newton. And as you can see, it's going to the right. So when we talk about a vector, we talk about a quantity that has a direction and has a magnitude, meaning the size. And one thing that you should remember is that whenever it's going to the right, it will take the positive sign. And should we have another vector going in the 180 direction, meaning going to the left, it's going to be a negative vector. So it can have negative 200 Newton because it's going to the left. So it's a quantity that has a magnitude and its direction. We want to know where is it going. All right. Now, we are talking vectors in 2 dimensions today. In 2 dimensions, I have very interesting question here that is going to require some of grade 10's knowledge, and most importantly on your what we call on something called sine rule. It's something that is going to solve all the mysteries that you have when it comes to vector diagrams. By the way, I want to start with an example here. So that we understand each other. Once we understand each other, then we won't have some problems. I want us to quickly look at the first example where we are working with horizontal component and vertical component. I believe it's something that we need to learn before we do everything. We just need to understand what vertical components are and what horizontal components are. Okay, now let's look at this first example, and then I believe it will be better. Let's look at this example. In this example, we said to you a force of 400 Newton, acts at an angle to the horizontal. Calculate its horizontal. At an angle of 60 degree. I forgot. A force of 400 Newton acts at an angle of 60 degree to the horizontal. Calculate its horizontal and vertical component. Remember, I'm just doing an example here, so you must listen very carefully. It's just a quick revision of something that we need to do, because I'll be talking about some trig ratios so that our life becomes better when we have to work with vectors. Okay, so it's very, very important that you understand your trig ratios as well. So now remember that an angle is being given, and we understand one thing, that when we have a line, when we have a horizontal line, it doesn't have an angle it doesn't have an angle because you have 0 angle there. And then the vertical line that will form a 90-degree with the horizontal line is definitely 90-degree angle. So this will be 90 degrees angle. Understanding now that we have been given an angle with 60 degrees angle, a vector or a force with 60 degrees angle. 60 is going to be somewhere between 90 and 0. So you can draw that line over here. And you know that angle will be caused by an x-axis, and the force itself, meaning you will have a 60 degrees right over here. All right, right over here. And then now this will be your 270, this will be your 180. And now it is pointing to the right. That means our 400 Newton is a positive force because it's going to the right. Now, I'm going to take you back to our maths class now, because that's where you need to understand. And when we talked about trig ratios in our maths class, because I don't believe we have a maths learner, a physical science learner who does not do maths. So we now understand that when we talk about trig ratio, we have been introduced to SOHCAHTOA, in grade 10, and I believe remember. So I'm just going to do that revision. So now we now understand that this is for sine. So is for sine, meaning opposite over hypotenuse. Opposite over hypotenuse. Car is for cos, adjacent, for cos, which is adjacent over hypotenuse. T is for tan, meaning opposite over adjacent. I'm just doing a very quick revision because I believe at this stage we understand or we remember these trig ratios. And something that you need to understand is the issue of a triangle itself. When we have a triangle like that, I can have my theta here and I can have my theta over here. There is a huge distinction between these two. Because if I want to identify my hypotenuse, it's easy because hypotenuse is created by two lines that will give you a 90-degree angle. So whenever we add a line to join the two lines, then we have a triangle. That line is called hypotenuse. So obviously this is our hypotenuse. This as well is our hypotenuse. It's our hypotenuse. How do we identify the opposite? This is how you identify the opposite. When you have a theta, you point to the side that is opposite to the theta. That is your opposite. Then you'll be left with adjacent. That means the other side will be adjacent. If it's going to be a triangle looking like that with this angle, then you go down there and then you have the opposite. Opposite will always be a side that is opposite to the angle. That means you'll be left with hypotenuse. Having this now, we can create our triangle now, because we're going to close this thing up and have a triangle. Then we're going to have what we call vertical component. Vertical component is RY, because vertical is a line that is vertically like that. That is vertical like this. And then now this line over here, this side, you'll have your horizontal component, and it's going to be RX. It's going to be RX. Now, we need to calculate the horizontal and the vertical component. Now, let's go and find out how on earth we're going to have to do that. Now, I want you to pay close attention. We're going to need this to do our problem, even your future problems. Now, let's start with vertical, horizontal component. Let's see, horizontal component. Now, with horizontal component, You need to understand that whenever you are doing horizontal component, you must use only the cos. You must use only the cos. All right. Now, as a result, you are going to start with cos. So you have cos theta will be equal to, remember, cos according to SOHCAHTOA is car. So having a 60 here, the side opposite to that 60 is our opposite. The longest side is hypotenuse. This side is our adjacent. According to car is adjacent over hypotenuse, meaning you have Rx over the hypotenuse. That's where your 400 is. So it's a force, this one. It's a force, so we are going to say a force or a vector. You can say a force or a vector, by the way. And then now you keep going, you say cos. Theta is an angle, so you're going to use this angle. You have 60 equal to, you are looking for horizontal component because Rx is the horizontal component divided by the force or the vector, which is 400. Now we're going to apply our maths. How do we apply our maths? We multiply both sides by the denominator because we need to clear the fraction. And to clear the fraction, you multiply both sides by the denominator. So we multiply both sides by 400. So this one, the 400 will cancel the 400. You'll be left with Rx. Now, if you take 400 and multiply with 60, you can quickly go to a calculator and do that. By the way, I'm already done. I'm faster than you. It's going to be 200 newtons. So we succeeded in calculating the horizontal component. Now let's go and calculate the vertical component. We have vertical component. Right, so we have vertical component. So when you calculate vertical component, you say sine theta. So you are always again and say sine. You're gonna use the, what happened? Oh, now you use sine 60, then equal to, then your ry, you are looking for your ry, then divide by the force, which is 400, and you are going to apply the same method again. You multiply both sides by your denominator, which is 400, which is 4. Cancel that, you'll be left with ry. Then if you say 400 multiplied by sine 60, now you can be quick about it. It's going to give you 346,41 newton. That's how you calculate vertical line, vertical component and horizontal component. So that's what you basically do. All right, now have your notes and write what I'm going to do now, because you are going to definitely need this. You are definitely going to need this. You as grade 11s, it is not introduced to you yet, but it is going to be part of your mathematics paper 2, and we call it sine rule. You call it sine rule. All right, you are in grade 11 now, and you'll be introduced to what we call sine rule. So I want to help you with your maths and your physical science at the same time. Please pay close attention. When we talk about a sine rule, we talk about this formula: side A divided by sine A. I want you to memorize this formula when you'll be writing your physical science. You're gonna need this. Side A divided by sine A will be equal to sine. Now, with that, I want you to remember that we use as, remember, when you have something like that, and I give you 40 or I give you 30, then I give you 4 and I give you 5, sorry, and then I give you x, and then I say to you, can you calculate x? You'll say, okay, for me to calculate x, I need to identify the sides that I have. So I have an angle, that is my opposite, that is my hypotenuse, that is my adjacent. So hypotenuse and opposite, they give me so. is opposite and hypotenuse is a so. Therefore, I'm going to say sine 30 divided by, now so is opposite over hypotenuse. Opposite over hypotenuse, it's 4 over x. And then you cross multiply both sides by x. X will cancel x. Then you'll be left with 4. And then x sine 30. And then you divide both sides by sine 30. It's just an example. So x will be the value of sine 30 divided by 4. 4 divided by sine 30. 4 divided by sine 30. And then that's how you find it. So what do you do now when you have a triangle that does not have a 90 degree? For example, 60, 40, and 80. What are you going to do? You don't have opposite, you don't have hypotenuse. Those are only when you have the 90 degrees triangle. If you don't have a 90 degree angle, you do not use trig ratios. You're going to use a sine rule or a cos rule. But in these vectors, we are only going to work with sine rule. Okay? Now check how sine rule work. If I'm going to say to you, let me not give you this angle. Let me give this angle a beta. Let me give this angle beta. And then have 4, rather, let me say x, 10, and 12. And I say, can you go and find the value of x? You are definitely going to say, yes, I can. So you're going to have to name your triangle. You can give this triangle, actually, by the way, you are looking for A, so you can say this is my A, this is my B, this is my C, A, B, C. By the way, this angle, this formula keep on going and say sine C, but basically you only have to work with 2 fractions. You work with 2 fractions. We're gonna ignore that C, meaning you are not going to give this angle a C. That would be very, very stupid. That would be very, very stupid. A, B, C. You are going to stack because your formula does not have a C. So at least give this a B or an A. I believe it makes sense. So let's give this an A, B, and a C. Now listen very carefully now. You are looking for the X. If you are looking for this side, listen carefully. If you are looking for this side, you need this angle. And then you go, your A is X now. Your A is X now. You say divide by a sine. You need an angle that is opposite to that side. Then it's better. What are you going to do? You can't say better here. You can't do that. You need to know that, this angle, any triangle must add up to 180 degrees. So what you're going to do now is to say 180 minus 40 minus 60. By the way, 40 and 60, that will give you 100. So you are going to have 80. You're going to have 40. I think it's 40, is it? How much is 180 minus 80? So not 60, it's 80. My bad, it's 80. So 80 and 40 is 120. 120 minus 180, that is 80. That's 40, man. Well, just work your calculators. I'm just giving you an example. Suppose we have a 50 here. Suppose we have I think it's 50, man. It's 50 or 60. Doesn't matter. It doesn't matter. Just work your calculator. As long as when you say 180 minus 40 minus the 80, whatever angle that gives you, then you're gonna put it here. I'm just gonna go with 80 for now. Just giving an example, by the way. Your B, then you can choose. Okay, this my B. My B is 10, and then if you use this side, you need that angle. So you're gonna go with a sine 80. Then you are going to do like that. You're gonna ignore your C because you don't need to use this one. You need 2 fractions. So my advice go to avoid the C. All right. Therefore, you cross multiply. X multiplied by sine 80 equal to 10 multiplied by sine 50. Then you can divide both sides by sine 80, divide both sides by sine 80, cancel, x will be equal to whatever value you are going to get there. So I just wanted to introduce the sine rule. I just wanted to do what? To do the sine rule. All right. Now, let's go back to the vector now. Before we treat our question, let's go to the vector. In most cases, we can give you a vector going in that direction. Can give a vector going in that direction, and then we identify its angle, maybe angle 30. And then we give you another one going down like that, you know, another one going that way like that, and then another one going let's say maybe going in that direction again, going in that direction. Can you form a closed vector? Can you form what? By the way, let me make it go like that. Let me make it go like this. Yeah, let me make it go like that, and then with 30 here. Yeah, with 30 over here. When we measure that, we get 30. Can you form a closed vector? When you form a closed vector, you must form a triangle using these three. You first take this one, plug it there, you know, just plug it there, and you must use tail to tail, you know, then plug it there, and then take this one, take this one, take the way it is, and then plug it there. Then you're gonna take it here, you know, gonna take it here, and then now you need another one to close. So let me try, because I'm trying to form something very useful here. Let's say maybe it was going in that direction. Yeah, let's say it was going in that direction, and then you take the way it is, and then we gave you 30 here, and then you take the way it is, and then you plug it here. You plug it here, and remember where it comes from. It gave you 30. It gave you 30. So this would be 90, and then you can definitely figure out the other angle right over there. So it's just you taking opened vectors, putting them together to form a triangle. All right, I'm doing that because our problem is going to need us to do that, and I'm gonna need you to pay close attention. It's a very, very, very beautiful question. Very, very beautiful question. Now, well, as the caption says, 2014 November, paper 1, Fiscal Science. We have been given an object. We've been given an object. That object was given 800 kg. So let me read that problem. They said the diagram below shows a rope and pulley arrangement of a device being used to lift an 800 Newton object. Assume that the ropes are light and inextensible, and also that the pulley is light and frictionless. Well, they are just trying to show you what I'm drawing now. So even if you don't look at that question paper, it's okay. So it's like something was hanging like that, something was hanging like that, and there was another force going in that way with a pulley, and there was another force going in that way. You know, it's like we're trying to pull this thing, and then going in that way, and then there was another pulley. All right. And then that means when you pull these things together, when you pull them in that way, this thing will be going up, it will be lifted. And they gave this thing 80 Newton. They said it's 80 Newton. By the way, that is the weight. We understand the weight. We have a formula of weight is mass multiplied by the gravity. Maybe they took 800 and then multiplied by 9.8 to get the Newton, but that doesn't matter. I don't know what they did. What I know is that they said the weight is 800 Newton. We have been given the weight. let me dive away just a little bit. You are now introduced to the word tension. You are introduced to the word tension. What does it mean? Well, tension, let me take it like that. You and your boyfriend, you and your boyfriend are arguing, are really having a serious quarrel. You are exchanging words. Why are you fighting? Well, that's because your boyfriend is believing in something else and you are believing in something else. Just for an example, don't mind me. All right. So that means you guys are not agreeing on the same thing. You are not agreeing on the same thing. Then there is a tension between you two. It can be a tension that will last 2 weeks. I don't know if you can handle that much, but by the way, we are trying to say tension. Whenever you have a rope, I'm going to give an example with rope. It can be a rope or it can be a string. Understanding that your girlfriend is pulling in that direction, you, my guy, you are pulling in that direction. There is a tension between you guys. That tension is how tight the rope is. How tight the rope is. The more your girlfriend is pulling in that way and you're pulling in that way, at the end of the day, the rope will break. When it breaks, it's not gonna be nice because you're gonna be dumping each other. So it's gonna break. You understand? So it's going to be more tighter to a point where it breaks. Now that means a force is broken. There is a force between you two. You are pulling in that, someone is pulling in that way, someone is pulling in that way. So that force is going to be created. So there is a tension that will be created on the rope. But when no one is pulling, there is no tension on the rope. So now you'll be introduced to the word tension. I want you to understand why now. We're gonna name this rope tension 1. They said this rope is T1. So the word T stands for tension, and then this one is tension 2. All right. That's not all. They said this angle, an angle caused by this by this tension and this tension right here. Well, this will be tension 3, by the way, because now there is a rope that is holding an object, and these forces, the tensions are being pulled up. So there is another tension here, by the way. There is another tension here. So an angle caused by this rope and this rope is 120, and the angle that is caused by tension 2 and this rope is 140. All right, so that is the information that was given. And on 2.1, because that question is on 2.1, they said calculate the magnitude of tension 1 and tension 2. The magnitude of tension 1 and tension 2. Now, how are you going to do that? Or how are you going to begin? How are you going to do that? Let's start doing this. You now understand that, by the way, I can form my Cartesians here. You're going to form a plane, meaning you have a horizontal line. You have a horizontal line. And then you have another vertical line. I want you to understand this is what you'll be doing in the exam. You have vertical line, something like that. Vertical line. This is x-axis, this is y-axis. Do you now understand that in that case you have a tension 1 going in that direction, tension 1 going in that direction, and as a result this angle is 120, and since it's 120, you want to know this angle. Now this is 90, remember, so you're gonna take 180 and then subtract this portion. Is 120 minus 90. This one is 90. Then you'll get 30 degree. You'll get 30 degree, and you have another one going in that direction, and then now the whole angle, it's 140. You take 140, you subtract the 90 again, you get 50. You get 50. It's going to be 50. You get 50. And there's another one going in that direction. It doesn't have an angle. It doesn't have an angle. So you are not going to give vertical lines 90 or anything or 270. Just they don't have an angle. Now, you are going to form a closed vector. I beg you, please approach it in this way. Go and form a closed vector. Closed vector. Having a closed vector, let's start with this one. We have another one going in that direction. Right? And that was our 180. 800 man. That is 800 Newton. Is this one? Is this force going downwards? The weight is 180. Okay, it's 800. I mean 800. What do we see? We see this one. Can we, if you draw a line like that, and then this one, and then you put it here, you are not going to have a closed vector. So we're going to take this one, the tension one, and put it here. And put it here, you know, and put it here, because you need tail to tail. That is tension one. And tension one, if we were to form, remember that tension one has, listen carefully, you are always creating a Cartesian plane. You have a 30 here, understanding that this angle must be 90 degree. So 90 minus 30, that will give us 60. So we'll have 60 there. We have 60. And then this one is going to close up now. It's going to close. Now you successfully closed. You successfully closed. You did what? Successfully closed. Let's come back here. Do you now realize that if you form a triangle with 90 degree, because this line is parallel to that line, you know, is parallel to that line. Now, every triangle must add up to 180. So 180 minus 90 minus 50, you're going to get 40 there. So that means you are having 40 here. Say, why do you do that? That is because it's a vertical line and my vector. So the same angle they created there, it will be the same angle that is being created here. Now, every triangle, listen carefully, every triangle must add up to 180. Guys, it must add up to 180, meaning 180. I want to figure out this angle. 180 minus 40 minus 60, it will definitely give me 80. So I'm going to have an 80 right over here. Now I have my beautiful, this is tension 1, this is tension 2, by the way. That is tension 2. It is going in that direction. It doesn't matter whether you see it going in that way. No, you count it from the point of contact. Is going in that way, is going in that way, this one is going in that way. All right, doesn't matter whether it bent and went on the other side. You only consider it from here. Now we're gonna go back to our sine rule. That's why I started with the sine rule. You're gonna have to pay close attention. Remember, I said, guys, you are only going to use a sine rule when you don't have a 90 degrees triangle. If it was 90 degree angle, we were going to use a vertical component, meaning cos theta will be equal to Rx over that force. So we are not going to do that. So I'm going to remind you our sine rule. You are going to say, A over sine A will be equal to B over sine B, right over there. Now listen carefully, because I'm going to remind you. Let's start with tension 1. Looking at tension 1, do you now realize that looking at tension 1, you are going to look at this angle, isn't it? You are going to look at this angle. So this is our A. You have nothing there. You can't use B. Hey, you'll be lost. Use this side because you have a value, you have a value. So make it a B. make it a B. Therefore, your A is tension 1. Your A is tension 1. Your A is tension 1. All right? Your A is tension 1 over sine. Which angle are you going to use? 40. You're going to use the 40 because it's the angle opposite to this side. So you use 40 equal to. Now come this side. Having this side, which angle? You guessed it right, is going to be that one. So that is your B. Your B, because you are here, your B is 800 divided by sine 80. Sine 80, which is this one. Then you're going to have to cross multiply. Well, tension 1 multiplied by sine 80 equal to sine 40 multiplied by 800. You divide both sides by sine 80. You divide both sides by sine 80. Sine 80 cancels sine 80. You are now left with tension 1 will be equal to, then you do that one, it will definitely give you 522.16 Newton. That is the value of tension 1. They wanted that. And remember that 2.1 was 7 marks. So you can't lose it. It was 7 marks. All right. Now, done with tension 1. Let's go for tension 2. Let's go for tension 2. With tension 2, if this is the side, we're going to use this angle. We're going to use that angle. So this will be our A now. Well, don't use B because what? Don't use tension 1. Tension 1 was 522.16. But what if you were wrong? So you can't use this one as your B. Go and use this one as your B because it was given. You understand? And then go and say, my A is tension 2. See? Then over a sine. Over sine. Remember, you're using tension 2 with sine 60. You're going to use sine 60 and then equal to. And then your B is 800, not 1000, 800 divided by 800. You are still going to use a sine 80 because 800 and that sine, that angle opposite to it. You cross multiply tension 2 sine 80 equal to 800 multiplied by sine 60 because you're going to multiply the 2. You divide both sides by sine 80. Sine 80, this cancel, tension 2 will be equal to. And then now you divide the 2. 800 multiplied by sine 60 divided by sine 80. It will definitely give you 703.54 Newton. That is the value of tension 2. Please watch this video more than once until you understand what you need to do. You will definitely be fine learners. Please work hard and remember what I taught you. I gave you methods that will help you in metric. As long as you are doing mathematics, this method will definitely work for you because on paper 2 you'll be doing cosine rule, you'll be doing sine rule and cosine rule. So they will help you to figure out these vectors quite nicely without any complications. So please let me know if this lesson was beneficial to you. I will definitely see you later. Bye-bye.